Alright, here goes some graph analysis. Graph analysis is a pretty useful tool from time to time, especially in this chapter when we start factoring polynomials that start at like x to the fifth, and factoring might take you, 4 or 5 steps just to do one problem. Knowing where you're going and where you're going to end up and being able to solve, graph analysis is a pretty useful tool. So a couple things. You're going to have to know how to find intercepts. Now the y-intercept is when x is 0, and you will only have one y-intercept in a function, because a function must pass the vertical line test, and if you had 2 y-intercepts, well, it's pretty easy to see that you would not pass the vertical line test. Now x-intercepts, you can have multiple. They're also known as your zeros. They're also known as your real solutions. So to find that, that's when y is 0. A local max and a local minimum. The local max is at the top of a section of the graph, especially when you have curves, obviously. And then you have a local minimum, which is at the bottom. So let's give you a pretty extreme example of a polynomial that has a few local maxes and mins. There you go. So the local maximums would be at the top of these two arches, and your local minimums would be at the bottom of those two arches. And that's that. That's a local max and a local min. So what we're going to do here really quick is we're going to analyze this nice simple graph. This is just for practice purposes. They're not always this pretty of an equation to work with. So what's our y-intercept? We can see that the y-intercept is at 0, 7. What are our x-intercepts? We can have multiple. So if we look across here, we have a -8, 0, we have a -3, 0, and we have a 4, 0. I'm sorry, a 5, 0. Our local maximum, that's at the top of the graph somewhere, so that's right here at 1, 9. Our local minimum, that's at the bottom right here, so this is going to be -6, -5. And of course, end behavior from the last video. As this graph is going to the left, what is it doing? It's going up to positive infinity. And as this graph is going to the right, what is the graph doing? It is going down to negative infinity. And that is how you analyze a nice, easy graph. So here is another nice, easy graph for you to work with. I would like you to list all the information. Pause the video and go. And it should look a little bit like this. You have your one y-intercept at 0, 8, which also happens to be one of your local maximums. We also have our x-intercepts at 2, 0 and -7, 0. You have a local minimum at -2, 2. Your other local maximum is at -4, 4. And your end behavior from the other day, as you go left and right, this is an even negative, so it's going to be going down, so negative infinity for both your f of x from negative infinity and positive infinity. Now, while we're here, I just want to let you know that this is the very, very top of the graph. That's known as an absolute maximum. So for right now, you don't really need to be able to distinguish absolutes and local. So for right now, if I ask you to find a local min or a local max, you find all of the bottoms and all of the tops. You don't worry about which one is absolute or local. So now we're going to use our graphing calculator. Like I said, the graphs above were nice, pretty, and already graphed out for you, but that's not the way it's going to work most of the time. Most of the time, I'm just going to give you an equation, and you're going to have to analyze it. And if it doesn't fit nicely on a graph, it's going to require you to use your graphing calculator. So this is a time where you're going to pause this video and go get your graphing calculator, and I will get the screen set up so you can see my graphing calculator so we can step you through it from beginning to end. And then this lesson is almost finished. So here we go. Set up with our graphing calculator. The first thing you're going to want to do is obviously type this in the graphing calculator. So go press your Y1 button and make sure you clear everything out in here that you don't need at the moment, and type the function in 2x cubed plus 3x squared minus 4x minus 5. And what we're going to do is we're going to press zoom 6 to make sure we all have a standard window. And that's what our graph looks like. So we're going to sketch it really quick just to help us out. So our graph looks a little bit like this. Now we have to go find all of our information. So to find the y-intercept, that's a very easy thing to do because remember, you're only allowed to have one y-intercept, and that is when x is 0. So you just look at the table. So press second graph and go look at where x equals 0, and you will see that y is a -5. So your y-intercept is at 0, -5. That's it, plain and simple, you're done. To find your x-intercepts, sometimes that's easy and sometimes it's a little bit tricky. So what do we do here? First, remember we sketched it. We know that we have to go find 3 x-intercepts. So the first thing you can do is look at the table and see if you can find anywhere, y is equal to 0. Because remember, y is equal to 0 is when you have an x-intercept. So we look through, it doesn't look like it's a very big window. If we look at the graph again, it crosses the x-axis pretty much between -3 and a +3. So you go back to the table and just look. So I see 1. At -1 we have a 0 for y. And let's go a little further just to make sure. And that's the only pretty one we have. So we know that one of them is going to be located at the coordinate -1, 0. So what do you do when you don't have some other pretty ones? Well, that's when you do the second option and just find the intersection of the graph and your x-axis. The easiest way to do that is to go back to y equals, and in y2 you type a 0. And you go back and you press graph, and what that does is it actually graphs a horizontal line right on top of the x-axis so you can find the intersection. So we already found the -1, 0. We have to go find the other one to the left, and we have to go find the one to the right because they're not pretty numbers. So you just press second trace, and number 5 is intersect, and you're going to take your little spider, your little blinky thing, and you're going to take him to the left as far as you can go right here, and you want to get kind of close. And now once you're there, you just need to click enter 3 times. 1, 2, 3. The graphing calculator will do the thinking for you and tell you that your furthest to the left, this intercept right here, is -1.851, 0. And now we have to do it one more time. Remember, we already have -1 right here. And then we need to go get the one to the right. So you just press second trace, number 5 again. But now you're going to take your little spider, and you're going to take him all the way to the right side. Again, you want to get close. So it looks like right there is as close as we can get. Click enter 3 more times. And it tells you that one to the right is located at 1.351, 0. So now you have your x-intercepts. Again, if they're nice, pretty, and easy, just look at the table and find where y is 0. But if not, you got your graphing calculator anyway, which can do all sorts of fancy things. Finally, to find the local minimum and the local maximum. We can find a local minimum by pressing second trace. And we're going to go to number 3, which is a minimum. And it says left bound. So what you want to do first is make sure you're working with the minimum, which is down here. So you go to the minimum and you press left a couple of times, once or twice, and that's your left bound, so you click enter. Now the calculator says the right bound. So you need to go to the right side of your minimum. So go to your minimum and press right a couple of times, and we're going to click enter again. And now it says guess. Now you want to put your little spider where you think the minimum is. It's approximately right there. You press enter one more time and it will find the minimum for you. So your minimum for this is at 0.457, -6.011. That is your local minimum. To find the local maximum, it's the same process. The only difference is you go to second trace, and now maximum is number 4. So you have to go to your maximum, And once you get there, you press left a couple times, 2-3 times to get to the left side, but not too far away. Click enter. Now you go back to your maximum and you click right a couple of times so you can go to the right side, click enter, and then you go back to the top and you're going to guess, and you're going to find out that your local maximum is at -1.457, comma 1.011. And there you go. So that's it for using your graphing calculator to analyze a graph. Now I'm going to take it just a step further with these X-intercepts, and then we are finished for today's lesson. Let me open this back up. This is just a little bit of thought process when you look at some kinds of graphs. So I'm going to draw just a couple of graphs. And we're going to just talk really quick about types of solutions that you might have. So I'm going to tell you that this is an x cubed graph, and I'm going to make it look like this. So when you're looking at this, it crosses the x-axis 3 times. So that means we have 3 real solutions. But remember, we can also have imaginary solutions from back in the day. Now, if it has 3 real solutions, you do not have any imaginary. So you're going to have a total of 3, unless you have what's known as a double root. We'll get there in just a minute. So for this second graph, I'm going to make this an x to the 4th graph. So x to the 4th could look a couple of different ways, but we're going to make this one look like this. So as you can see here, we cross the x-axis 4 times. So we have how many real and how many imaginary. So if it crosses the x-axis 4 times and it's an x to the 4th power, we have 4 real and 0 imaginary. So now let's mix it up a little bit. Here's an x cubed graph, and we're going to make him look like this. So since we have an x cubed, we're going to have 3 solutions here, but it only crosses the x-axis once. So we have 1 real solution. So if 1 is real out of 3, that means the other 2 are imaginary. Okay? So one last graph. We're going to make this one an x to the 4th again, but I'm going to make him look like this. And we're going to touch the x-axis 3 times. Now, there's the trick. This is a trick one. We have 3 real. How many imaginary do we have? In this special case, we have 0. And here's why. Whenever you cross through the x-axis, that's 1 real solution. But whenever you bounce off of it like this, this is known as a double root. Whenever you bounce off of the x-axis, that counts as 2 solutions. So that would be like an x plus 1 and x plus 1, which would give you a -1 twice. Okay? This is just a little bit more going beyond to help you analyze these graphs. Okay? So that's it for this lesson, a little bit of graph analysis. Quiz is coming up soon. This is Longo, and I am out. See you. Bye.